In Lesson 2-4, we're going to review U.S. Traditional Multiplication, Part 1. You'll find that we'll spend a couple of days on different multiplication lessons. So let's go ahead and grab our whiteboards, our whiteboard markers, and our math journal and get started. For our warm-up, please number on your whiteboard number 1, 2, and 3. You are going to multiply and write your answers on your whiteboard. So we're taking a basic fact of 7 times 6, multiplying it by a power of 10 and an extended fact. So let me give you an example for the first set. 7 times 6 is 42. If I look at what's in parentheses, 6 times 10 to the first power would be 60. There's my 1 0. 7 times 6 is 42 with 1 0. And 7 times 60 is 420. So you're going to do the same thing on your whiteboard. I gave you an example of the 3. Now I would just like you to write your answers. Remember, if you see a set of parentheses, you do that first. Remember, this is read 10 to the second power. Go ahead and pause your video and write down answers only. Make sure you're doing this so that when you get to 6th grade, you will have practiced all this and not just watched it. Go ahead and pause your video. All right, let's take the basic fact of 4 times 7 is 28. I know 10 to the second power means 100. 7 times 100 is 700. If I look at parentheses, 7 times 10 to the second power is the same thing as 7 times 100. And 4 times 7 is 28 with 2 zeros behind it, 2,800. Go ahead and erase your whiteboard. 3 more similar problems. Our basic fact is 9 times 7. Go ahead, pause your video, write down answers only. 9 times 7 is 63. Now let's extend that fact. 9 times 10 to the second power would be saying 9 times 100, which is 900. And 7 times 10 to the second power is 7 times 100, which is 700. All right, today we're going to go ahead and look at some multi-digit multiplication. How would you go ahead and solve 34 times 9? There are multiple ways to do it. I want you to go ahead and write down this problem and solve it. How would you do this? Go ahead. Some of you may remember from last year where we partitioned rectangles and we thought of 34 as 30 plus 4 and then 9. We called this partial products or partitioning rectangles. And then what we did is we just took 9 times 30, 9 times the value of the 330, which is 270, and then 9 times 4, which is 36, and then we added together 270 plus 36 to get 306. Some of you may have done what we call traditional, where we'll take 9 times 4 is 36, carry your 3 or the 30 over. 9 times 3 is 27. We add in the 3, we get 30 for an answer of 306. So we're going to look at different strategies to multiply. One of them is called partial products, and that is where you take the value of the 7 times the value of the 5. So 7 times 50 is 350. And then the value of the 7 times the 6, which is 42. Add those together, you get 392. The area model, or what we called it in 4th grade, is we called it partitioning rectangles. We look at the 56 as a value of 50 plus 6. 7 times 5 is 35 with 1 0, and we extend that fact. And 7 times 6 is 42. It looks just very similar to the one on the left here called partial products. But just remember, you get to the same solution. So some of you may find, wow, when I did this in 4th grade, this was easier, or maybe this one was. What we're going to take a look at today is what we call U.S. traditional multiplication. So this is not in your math journal yet, so you're going to go ahead and need your whiteboard. If you have not mastered your multiplication facts yet, I cannot encourage you enough to be practicing those at home so that they become automatic. So go ahead on your whiteboard and write 26 times 4. This may be review for some of you, but we are basically multiplying a 2-digit times a 1-digit. The first thing we're going to go ahead is multiply 4 times 6. 4 times 6 is 24. Again, use that multiplication chart inside your math journal or in your math manipulative kit. But we're going to take 4 times 6 is 24. We write down the 4 and we carry our 2 in 24 over to the tens place, the next set of numbers we're going to multiply. Now we'll take 4 times 2, which is 8, add in the 2 we carried to get 10. The solution to that multiplication problem is 104. All right, let's take 41 times 8. Starting with some very simple ones to begin with. So we're going to go ahead and multiply the ones. 8 times 1 is 8. Nothing to carry over, so we multiply the 8 times the 4, which is 32. The product is 328. So those are some real simple problems to begin with. So we're just going to start out that way, and as we progress, we'll get more challenging problems. Let's go ahead and open to journal page 48. Remember, if I am doing a multiplication problem or any type of problem in the math journal, you should be writing it as well. If I check your math journal, I should see all of the pages that we've done in our videos completed in yours as well, including where you have to carry over a number. I want to see that part done as well. So it says practicing multiplication strategies. For problems 1 and 2, solve one problem using U.S. traditional multiplication. Solve the other problem using any strategy. So if you found that you liked partitioning rectangles, you can go ahead and do that. I'm going to do number 1 with traditional. So the first thing I'll do is take 6 times 3. 6 times 3 is 18. Put down my 8 and carry my 1. Now I'm going to multiply the 6 times 2, which is 12. Add in the 1 that I carried over, which is 138. Now, just to show you how we did this last year, I'm going to take 76 times 5. And I'm going to think as 76 is 70 plus 6. So they're just becoming either an extended fact or a basic fact. 5 times 7 is 35 with 1 0 behind. And 6 times 5 is 30. I add those two numbers together. I can do that in my head. 380. Number 3 says choose problems 1 or 2. Explain how you check to see whether your answer made sense. Well, if I take number 1, if I estimate 23 is closest to 20, I take that single digit of 6. 2 times 6 is 12 with 1 0 behind it. And I could see that my answer made sense. It was close to 138. The other way I could check my work, if I took number 2, I could just do a traditional method instead of partial products or partitioning rectangles. 5 times 6 is 30, carry my 3. 5 times 7 is 35, plus 3 is 38 for 380. So I could check it one of several different ways. For problems 4 through 7, do the following. Write a number model with a letter for the unknown, what we call a variable. Solve the problem. Use US traditional multiplication for at least one problem. Show your work and write the answer. So let's start with number 4. Paula has 7 decks of cards. Each deck of cards has 52 cards in it. How many cards does she have in all? So I'm going to take 52 times 7, and they use the variable C. I'm going to use my space here to write out 52 times 7. I want to see that you're not doing this in your head. I want to see you show your work. At any point in time, if you need to pause the video, go ahead and do so. 7 times 2 is 14. Put down your 4, carry your 1. 7 times 5 is 35, plus 1 is 36. How many cards does she have? She has 364. Number 5, a bush is 21 inches tall. A tree is 5 times as tall as the bush. How tall is the tree? I'm going to do one more with using US traditional multiplication. So I'm going to actually write my number model, which is 21 times 5 equals a variable, which a letter stands for what I'm solving for, the unknown. And then over on the side, I'm going to take 21 times 5. Go ahead and write that down. Using traditional multiplication, going to multiply 5 times 1, which is 5, and then 5 times 2, which is 10. How many inches tall would the tree be? 105 inches. Continuing to number 6. A fence has 45 sections. Each section is 6 meters long. How long is the fence? I'm going to use partitioning of rectangles. I'm going to think 45 is 40 plus 5. I think of it in multiples of 10 because I can easily do those in my head, and it becomes an extended fact. And 6 over on the side. So now I'm going to take 6 times 40. Well, 6 times 4 is 24 with 1 0. And 6 times 5, which is 30. I can then add those together in my head. 240 plus 30 is 270 meters. Let's go ahead and write an equation. 45 sections times 6 meters per section gives me my number model. And lastly, an apartment building has 9 apartments on each floor. There are 43 floors. How many apartments are in the building? Here I'm going to use partial products. I'm going to begin by multiplying 9 times the value of the 4. 9 times 40 is 360. Now we'll take the 9 times the value of the 3, which is just 3. 9 times 3 is 27. Add those two together. 0 plus 7 is 7. 6 plus 2 is 8. Bring your 3 down. There are 387 apartments. Let's go ahead and write an equation. 9 apartments times 43 floors gives us what we are solving for.